Today we are going to discuss about work and energy. When we apply force on an object and object is displaced, then we can say work is done. When there is no displacement, work is not done. So here we can say this type of formula, that is the work which is done is the product of force applied on the object and the displacement through of the object. Okay, and the SI unit of work is joule. 1 joule is equal to 1 Newton meter. Newton is the SI unit of force, meter is the SI unit of displacement. Okay, so this is all about work. Now what is energy? Energy is the ability to do the work. The SI unit of energy is joule. 1 joule of energy is required to complete 1 joule of work. Okay. Now there are two types of energy: kinetic energy and potential energy. Kinetic energy is processed by the object due to the motion of the object. Okay, kinetic energy is actually half of the product of mass of the object square of the velocity of the object. It is half mv square. Okay, now through this diagram we can say force is applied here. The object is initial velocity u and the displacement is s and the final velocity is v. Work is done, and which is the product of force applied on the object and displacement. So W equals to Fs. Okay. Now previously we told equation which is v square minus u square equals to 2as. V is the final velocity, u is the initial velocity, a is the acceleration, and s is the displacement. So s is actually v square minus u square divided by 2a. On the other hand, force of attraction or force applied on the object is the product of mass of the object and acceleration of the object. So combining these two, we can say work done is equals to the product of mass of the object, acceleration of the object, and final velocity, square of final velocity minus square of initial velocity divided by 2 cross acceleration of the object. So after that we can say half m v square minus u square, because these two a are common here. Okay, now just follow this. If u is 0, then we can say half mv square. Okay, kinetic energy is the half mv square. Okay, now I am shifting to the next point, which is potential energy. Potential energy is possessed by the object due to the change in the position, change in the shape. Okay, actually this is the product of mass of the object, acceleration to the gravity, and height. Okay, in this diagram, the first position is A, the second position is B, the height is h, and the object is lying on the surface, and there is a force of attraction provided by the earth, force of gravitation, and the weight of the object is the product of mass of the object and acceleration to the gravity, which is mg. Okay, now here the s is, the displacement is actually h. We all know work done is the product of force and the displacement. Work done is the product of force applied and the displacement. So combining all these, finally we can get what? W is mgh. Okay, and what is that? The final result is how we can get these two. Kinetic energy half mv square, and by this procedure we can get this formula, and potential energy is mgh, and by this process we can get this formula. The next portion is the last portion, which is the law of conservation of energy. We all say that the energy is not created nor destroyed, but can be transferred from one form to another, and the total energy is any point is constant. Okay, in this diagram, the first position is B, the last position is C, the height is h, And the main rule is when potential energy is the high, the kinetic energy is 0, because when h is the highest, the velocity is the 0. When gradually the potential energy is decreasing and kinetic energy is increasing, and by this process, when potential energy is 0, kinetic energy is the highest, because the h is 0 when the velocity is the highest. Okay, this is the main formula, the main fundamental features behind this energy calculation. So we can say at the first position B, the potential energy is the product of mass of the object, acceleration to the gravity, and height. On the other hand, the kinetic energy is 0. And finally, at position C, potential energy is actually 0. Kinetic energy is half of the product of mass of the object, velocity means the final velocity of the object, and its square means half mv square. And from the previous equation, we all say that the square of the final velocity of the object means the v square, actually the product of 2 acceleration to the gravity and height means 2gh. So combining all these, finally we can say the kinetic energy is actually mgh, and from the first position, from the initial position, the total energy is potential energy plus kinetic energy is 0 plus mgh, and which is mgh. And from the final position, the total energy is a sum of potential energy and kinetic energy, and there is also mgh plus 0, and which is mgh. Okay, so in this way we can notice that at any position the total energy means the sum of potential energy and kinetic energy is actually constant. So by discussing work, energy, kinetic energy, potential energy, and the law of conservation of energy, I am ending my today's discussion, and I think this all discussion is going to be very much useful and informative to your studies. If you like this video, please go to the Google Play Store, download Knowledgeflame app, and subscribe Knowledgeflame channel, YouTube Knowledgeflame channel. Thank you.